Hello, this is Carl at lunchboxsessions.com. In this video, we're going to look at basic functions of a very important pressure valve called a relief valve. Many hydraulic systems use a pressure relief valve as the primary means to limit maximum system pressure. Without a relief valve in place, pressures could potentially build to an excessive level where the machine might be damaged or perhaps a hose might burst, endangering human lives. The type of relief valve we will be examining is the simplest style with only one poppet and one spring. It is known as the direct acting relief valve. This live schematic shows a fixed displacement pump sending a flow of 10 gallons per minute through the system. Our directional control valve will remain energized in the cylinder extend position. The relief valve is shown in cutaway form so that we can see all of the details and actions of the relief valve as it responds. The system pressure is indicating 200 psi, which is calculated by looking at the mass being lifted, 2,000 pounds, divided by the 10 square inch surface area on the bottom of the piston. The controls show that the relief valve is set to 300 psi. But how do we know this? The only true way to know the relief setting pressure is to observe the system in action and the values on the system pressure gauge. Let's add a 2,000 pound brick for 4,000 pounds total divided by 10 square inches, and we did not achieve 400 psi. The cylinder crashed back down to the bottom, and the maximum pressure on the system gauge indicates 300 psi. When flow from the pump can take no other path than through the relief valve, the pressure value on the system gauge then indicates the true setting of the relief valve. Let's add 3 more bricks for a total of 10,010 pounds. We would need to trap a system pressure of 1,001 psi to lift this load. Now, if we tension the spring on the relief valve, we notice that the system pressure is climbing as the relief valve poppet pushes against the flow. As the relief valve can only be adjusted up to 1,000 psi, we are unable to lift the load on the cylinder. We simply cannot trap the required pressure in the system. Watch what happens as we remove one brick for an 8,000 pound remaining load divided by 10 square inches for 800 psi system pressure. The cylinder starts to lift, but notice that the relief valve is not closed. Let's once again add a brick and remove a brick while watching the poppet in the relief valve. Removing a brick allowed the poppet to advance upward, but the relief valve does not quite close. Removing one more brick for 600 psi system pressure, we see that the relief valve has closed completely and that the cylinder has increased speed. Again, let's add the 4th brick and remove it while watching the relief valve and the cylinder. Remember that the relief valve is set to 1,000 psi, but clearly the valve opens at 800 psi and begins to direct at least some of the system flow back to tank. In this case, the cracking pressure is 800 psi, where the relief valve setting is actually 1,000 psi. The difference between the cracking pressure and the setting pressure for this particular relief valve is 200 psi. In order to lift the system at maximum possible speed with an 800 pound load, the relief valve would have to be set a little higher than 1,000 psi. In future videos, we will examine pressure override in more detail and look at more complex relief valve designs.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up.